Hi students, this is AJ sir. Let's study 10th standard ICSE Math chapter 21E, Trigonometrical Identities part 3. Exercise 21E. Let's start with question 1.4. Cancel Roman number 1 and 2 because they're very easy and of the same type. So we copy the LHS. We'll do the LCM. So into 1 minus cos A into 1 minus cos A into sin A into sin A, so that the denominators become common, which is sin A into 1 minus cos A. In the numerator, we open the brackets. A minus B the whole squared is A squared plus B squared minus 2AB. Now cos square A plus sin square A is 1. 1 plus 1, 2. So remove 2 common. We are left with 1 minus cos A in brackets, which can be cancelled with the denominator. That is why I didn't open the brackets in the denominator. So the RHS is reached. Next question. Roman number 5. That's an IMP sum. We start with the LHS. We'll convert everything into sine and cos. And we'll take the LCMs. Now remember, the denominator goes to the numerator, and the numerator's denominator stays in the denominator. So what we get is cos square A upon sin A brackets plus sin square A upon cos A brackets. Now again we'll do the LCM. The bracket is the same. So into cos A, and here into sin A. That way they will have a common denominator, which is sin A cos A minus sin A. And then bring the numerators together, which becomes sin cube A plus cos cube A. So here you need to remember the cube formula, which is cos A minus sin A, cos square A plus cos A sin A plus sin square A. So remember, A cube plus B cube is always A minus B, A square plus AB plus B square. Be careful about this negative sign, don't forget it. So again, this bracket gets cancelled. That's good. Also, cos square A plus sin square A is 1. So we reach this step. Now we'll start with the RHS. We'll convert everything into sine and cos, and even that would be similar to what we got for LHS. So LHS is equal to RHS, and the sum is over. Next, cancel Roman number 6. Let's do Roman number 8. Again, that is IMP. Now we see that there are 3 terms here. So it's tricky to find out the conjugate. We'll convert this in this format. Notice how the bracket is exactly same. That is very important. And be careful about the sign. Since I put minus sign outside the bracket, here this became minus, which is good because even here there is a minus sign. So this is of the format A minus B and A plus B. So now we can multiply with the conjugates. Use the conjugate of the denominator. So that will be a negative sign here. By doing this, the numerator becomes a whole square and the denominator becomes the format A squared minus B squared. Now we'll open the brackets. In the numerator, A minus B the whole squared becomes A square plus B square minus 2AB. In the denominator, just open this bracket, it will become A square plus B square minus 2AB. Still, keep the brackets here. There is a minus sign outside, so all the signs are going to change. Back again in the numerator, A minus B the whole squared, open it. A square plus B square minus 2AB. And here I have opened the brackets and changed the signs. Now what? Well, sin square A plus cos square A is 1. And 1 plus 1 is 2. Anything else? Sin square A minus cos square A, nothing. We can't do anything about that. So let's remove 2 common in the numerator. So if I remove 2 common in the numerator, what is left in the brackets? 1 plus sine A minus cos A minus sine A into cos A. In the denominator, 1 minus 1, so cancelled. 2 cos A as it is, and minus cos square A minus cos square A becomes minus 2 cos square A. The reason why we converted the sine square A into 1 minus cos square A was to make sure that everything in the denominator is in terms of cos. Because then we are able to remove 2 cos A common in the denominator and we are left with a bracket 1 minus cos A. On the other hand, in the numerator, since we have 4 terms, the first 2 terms will form one bracket, and from the next 2 terms, remove minus cos A common. So what is left in bracket here is 1 plus sine A. Now you can notice that this bracket is the same, so you can remove it common. So what is left in the second bracket? 1 minus cos A. Also, 2 and 2 got cancelled. That's good, because now in the next step, this and this can get cancelled. Is this the RHS now? Check. No, it isn't. So what would you do? Pause and think about it. Ready? Multiply with the conjugate. By doing that, automatically you'll get the RHS. Next, let's do the 10th sum. There's a root sign here. We'll multiply with the conjugate, but this time we'll use the conjugate of the numerator, because that way the numerator becomes 1 minus cos square A, which will ultimately become sine square A. And if you notice in the RHS, we needed sine A in the numerator. The denominator, on the other hand, becomes the whole squared. So the square root and the square disappear, and we are left with 1 plus cos A, which is the RHS. Next, the 12th sum. We'll start with the LHS. Now there is a trick involved here to make it a shorter sum. You can convert everything into sine and cos and solve. You will get the answer, but it will be very long. I'll give you a shorter method. The moment you saw cosec and cot, did any formula strike you? Well, that 1 can be written as cosec square A minus cot square A, right? Because cosec square A minus cot square A is 1. The reason why I'm doing this is because now this will become A minus B, A plus B. And I can see that the bracket is common in the numerator as well as in the denominator. You should be able to visualize this. So this will make our sum very easy. Now I'll just remove the bracket common. Whatever is left is in the second bracket. So now this bracket and this bracket gets cancelled, and we are left with the RHS, because in the numerator also this got cancelled. Next, 14th sum. That's an IMP sum. So we'll start with the LHS. I can see the denominator is of the format a squared minus b squared, although it's power of 4, but we can use that formula. So let's use it. It'll become cos square a plus sine square a, which is nothing but 1, and cos square a minus sine square a. So in the denominator, this bracket has disappeared, and this we shall convert it into sine square a. So this will become 1 minus sine square a, so that everything is in terms of sine. So this becomes 1 minus 2 sine square a in the denominator. The numerator is also similar, although with a square sign. So at least one of the brackets gets cancelled, and the only thing left in the numerator is 1 minus sine square a. If you notice, there were 2 such brackets, square sign. One bracket got cancelled. But this is not the RHS. RHS is in terms of cos. So again we will convert the sine square a into cos square a to get the RHS. Now you could have converted everything into cos square a right after this step. you could have converted this into cos square A and this into cos square A, because RHS is in terms of cos square A. That would have also worked out well. Now the 16th sum, again it's an IMP sum. We'll start with the LHS. First, open the brackets, distributive multiplication. This cosec raised to 4a is nothing but 1 upon sine raised to 4a. So let's convert it into that format, because cos upon sine is cot. And that would be better if we only have cosec and cot, because we do have a formula or an identity with cosec and cot. So this becomes a square minus b square format. We will write it as a square, a plus b, a minus b, out of which this bracket will disappear because that's 1. So we are left with something simpler. And then cot square a minus 2 cot square a is minus cot square a. This is also 1. So that's the RHS. If you convert everything into sine and cos, still you'll get the answer. Try it out. It'll be longer, but then you don't have to remember the formula you have to use in this sum. Next, cancel the question 2 and question 5 because they are easy. Actually, question 5 is not very easy, but in our syllabus, such complicated sums won't come. Question 3. Let's do that one. So x is equal to a cos theta is mentioned. I'll shift x on the denominator here and cos theta on the left hand side here, because I would like to square both the sides. In the question they have mentioned a square upon x square, so I'm trying to get that value. And of course 1 upon cos theta is sec theta, so squaring both the sides I get the value of a square upon x square. Similarly, solve and get the value of b square upon y square. And now we can use these values. We start with the LHS, we substitute the values, and this is a formula, an identity. So that's the RHS. Next, 6.2. Now this is a very different type of sum. If 4 cos square a minus 3 is equal to 0, it's already given. Show that, blah blah blah. So here we will solve and get the value of a first. We will find the value of a, the angle. If you remember the standard angle values which you have studied in 9th standard, you should know the trigonometrical values of 30 degrees, 60 degrees, 45 degrees, 90 degrees and 0 degrees. So let's solve it like a normal algebra sum. Minus 3 goes on the right hand side, it becomes plus 3. 4 goes down, square becomes square root, this becomes root 3 upon 2. So cos A is equal to root 3 upon 2. But cos of which angle is root 3 upon 2? Cos of 30. That means A is 30 degrees. And not because we can cut cos and cos, there is no such operation. It's simply by comparing, we came to a conclusion that A is equal to 30. So before moving ahead with such sums, please revise the trigonometrical table of standard values from your 9th standard textbook or from the internet. Learn them perfectly so that you don't just copy from here and use your own brain to find out the values. Now that we've got the value of A, the sum is easy. We start with the LHS, cos 3A, substitute the value of A as 30. So we get cos 90 and cos 90 is 0. Similarly, RHS, we substitute the value of A as 30. Now remember, this is cos cube A. Cos cube A is nothing but cos 30 the whole cube. And 3 into cos A, that is 3 into cos 30. Now what's the value of cos 30? Tell me quickly. It's root 3 upon 2. So we substitute that value. Root 3 cube, that is root 3 into root 3 into root 3 is 3 root 3. 2 cube is 8. Now here 4 ones are 4 twos are. So you get 3 root 3 upon 2 minus 3 root 3 upon 2, that is 0. That is how LHS and RHS are now equal. Next, question number 7 is not in syllabus, cancelled. Question 8 is not in syllabus, cancelled. And question 9 is not in syllabus, cancelled. Now let's do question 10. Roman number 1 cancelled, Roman number 2 cancelled, easy sums. Roman number 4, let's start solving that. We'll start with the LHS. We will convert everything into sine and cos. LCM, again LCM, to get the entire numerator together, and the common denominator is sine A cos A. Don't open the brackets yet. Notice how the brackets are same. So take the bracket out common. So what is left is sine square A plus cos square A in the other bracket, which is nothing but 1. So you're left with this. And then you can just split the fraction into 2 fractions. Cut, 1 upon cos A is sec A. Cut, 1 upon sine A is cosec A, and that's how you get the RHS. Next, Roman number 4 is done. So Roman number 6, which is IMP. Again a root sign here, but you'll have to manipulate the sum to get the RHS very easily. You want a shorter method? First convert sec square A to 1 plus tan square A, and cosec square A into 1 plus cot square A. So that becomes tan square A plus cot square A plus 2. But how do I get rid of the root sign yet? Well, for that 2, can we just add something, tan A into cot A? If you notice, this is nothing but 1, because tan A and cot A are reciprocals of each other. They can be cancelled. So we are not changing anything here. This is still valid. But by writing it in this format, this looks like a square plus b square plus 2ab, which becomes a plus b the whole squared, and the square and the square root sign go away, and we are left with the RHS. So how will you remember when to apply this method? You are right. Your answer is right, by practicing. Next, cancel Roman number 7 and 8. Again, very easy. Same type of sums have been done so often. Let's do Roman number 9 instead. But we have to prove this is equal to this is equal to this. Well, take this as a hint. So we'll first prove this is equal to this. LHS is equal to this. Then we'll prove the RHS is equal to this middle term. So both are equal to the same middle term. Hence, LHS is equal to RHS. That will be our strategy to solve. So nothing else is special about this sum. Very easy. We start with the LHS, we convert everything into sine and cos, we do the LCM. Now keep looking at the middle term. We got the denominator already, great. But the numerator is only in terms of cos, but we have sine also, so get rid of the sine. Convert the sines into the coses. Open the brackets. This gets cancelled, and we are left with this, which is the middle term, great. And now the RHS. First convert everything into sine term, LCM, we got the denominator, yay. But the numerator is in terms of sine, we want it in terms of cos, so convert the sines into the coses. When you open the brackets, automatically you'll get what is asked, and the LHS is equal to RHS, hence. Question 11 is of the same type, so you can skip it, cancel it. Question 12.1, easy, cancel. Let's do 12.2. Now, when they mention about A being an angle between 0 and 90, that's not very significant at school level. We can just solve it without worrying about what is this. Sine 3A minus 1 is equal to 0. So, minus 1 becomes 1. So, sine 3A is equal to 1. But sine of what is 1? Sine of 90 is 1. That means 3A is equal to 90. Not because we are cutting sine, no. It's simply comparing. So 3 goes down, A is equal to 30 degrees. That's what they wanted us to find out. Roman number 4. Here take out cos A common. So either cos A is 0 or this bracket is 0. One of them has to be 0, only then their product will be 0. So we'll get 2 answers, I guess. If cos A is 0, that means A has to be 90 by comparing. And if cos A is 1, then A has to be 0. By comparing. So 2 answers, 90 degrees and 0 degrees. And finally, 13.2. We can cancel 14, 15, 16. Again, very easy sums. The 16 is not even there in syllabus now. let's do the 13.2. We'll solve this and find the value of a. We don't have to prove this. They didn't say prove it. They said find the value of a. So we'll have to take the LCM first. I'm not going to convert sec into cos right now, although you can try that. It will work out. After taking the LCM, I'm left with this. Notice how the denominator became a formula, because sec square a minus 1 is tan square a. This was a minus b, a plus b, hence it became a square minus b square, and that became tan square a. Notice how the 2 and 2 got cut, or you can say 2 came down in the denominator and got cut, and 1 is left. Now you can convert this into 1 upon cos a, and tan square a will become sine upon cos, and the cos will go up, and I'm left with this cos cancelled, sine cancelled. What is left is cos upon sine, which is cot. So cot a is 1. That means a has to be 45 degrees because cot 45 is 1. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.